Computer vision datasets are getting larger and they require a lot of storage space. To take a recent example, the Leon 5 billion dataset requires more than 200 terabytes of disk space. Storing these massive datasets can be difficult and can get expensive, but we actually have options when it comes to storing training images for our machine learning models. With the given storage budget, we can either keep fewer images at a higher quality level, or we can lossily compress images, so each image is lower quality, but we can keep more distinct examples. With modern image codecs, there's actually a whole spectrum of options here, using different image compression settings. Typically, the default behavior for handling image datasets is to just leave the image in its as-is in its original format. However, we find that lossy image compression can actually offer a better trade-off between the number of images and the quality of each image. Models trained on these compressed images can result in a lower test error than the default in option 1. We trained models on different numbers of images and at different compression levels, and we find that test error is predictable. It follows a power law in both the number of images and the compressed size of each image. We can then use these scaling laws to optimize their image compression levels to minimize test error for a given storage budget. We compare these models to models trained on the original image format, where we just discard images to meet the storage budget, and we find that training on optimally compressed images can result in lower test error at ISO storage. Practically, this means that if you're storage limited, when it comes to keeping image training data, you may want to consider lossy image compression as an alternative to deleting examples to reduce the size of your dataset. If you're interested in learning more, check out our paper, Scaling Training Data with Lossy Image Compression.